called as a cue. So with the help of that cue, so in snooker, what happens? Are you permitted to push the ball, or you are permitted only to strike the ball? You are permitted to strike the ball, no? Hockey, football, cricket, badminton, tennis, table tennis, or snooker game. Most of the things, or you are permitted to push the ball till the hole. Means you have a long stick, in fact. So what happens? You can just push the ball till with the stick so that the ball will fall in. No, you have to only strike the ball. No. So when you strike it, what happens? You will apply impulse. You strike it the ball for small duration of time. That normal quantitative time will become impulse. So that impulse is what I'm applying. What all we discuss is related to snooker's game. All this. So if you want to become champion in snooker's game, you must have idea where to strike the ball in various situations. That's what the science is involved there, and how good you are in this particular rolling. All that one, if you practice yourself, where if you strike, how it will move, how it will rotate, that will determine. They'll become champion. So for that, every day you have to practice and make notice. Then you'll become champion. And just sir, I'm interested in snooker game. No, nothing will happen. Okay, no. So anything will happen to the this particular disc. An impulse will act, and because of that, it will acquire linear velocity. That's all. Nothing else is there. Sir, why it will not rotate? Because this impulse will pass through the axis of rotation. Oh. So no angular impulse by this. Apply the linear impulse. Because it will pass through axis of rotation is z-axis passing through O. This axis perpendicular to plane. So it will intersect axis of rotation. So friction. See, you applied impulse, then friction will come into picture. Okay, now look at the point P. What is the velocity of point P? Will be towards right. So how the friction will act? Backward. So then after some time, the disc will come here. It will acquire velocity v1 and omega 1. And again, I'll come and check velocity of point P will be towards right. It should be a forward slipping. Then finally, what when the friction does? Negative translational work and positive rotational work. And finally, it will attain pure rolling. I think we have done enough of problems. It's asking expression for that V. So shall we apply conservation of angular momentum? About what? About an axis passing through point P. LPZI equal to LPZF. What is LPZI? MVR, translation motion of center of mass, plus angular momentum due to rotating motion of center is 0. Finally, sorry, this will be MV naught, I'll write it. This will be MVR plus IO omega. Now this will be MR square by 2 into omega. Since for pure rolling, V equal to R omega. So what is the expression for V naught? R omega, you can write it as this will be 3V by 2. So V equal to 2V naught by 3. But V naught is what we assumed it, no? What to write V naught? When you apply impulse, it will acquire linear momentum. Impulse momentum equation, initial momentum 0, impulse acted, and finally it acquired momentum mv naught. So that you substitute here. 2 by 3. V naught will be J by M. All other things, just you have to express everything in terms of J. Fine. Okay, now the problem will become very beautiful as you start shifting this J. Let me shift the J up. I'll scroll down. Just notice everything. Again, this is a very important one. So can be asked in advance. We did all the problems where we applied a force. No, now we are going to impart linear velocity. Now you can ask questions, sir, how you imparted the linear velocity? By applying impulse. How to apply impulse? By pushing it suddenly, by kicking it, by striking it with some cue, anything like that. What when the body will acquire linear velocity? Let's come. Okay, same numerical. Let me apply. All of you, please be alert. Okay, there's one condition I am bringing. I'll apply impulse at highest point. Let this be a disk. Let me call center C here. This is a rough surface. Now get into the problem. Now, where do that particular impulse will act at highest point? I'll describe a disk of we'll take this. Impulse J on left on origin threshold. Find the velocity of this when it attains pure rolling. I read the question. Now, where it is applied at highest point. Now, tell me what are the possibilities the disk will have here. This at t equal to 0 it happens. When you apply this impulse, it will set up angular impulse about c. So it will have the rotational motion. It will have the rotational motion. So first the disk will be it will have angular velocity omega naught. Because of linear impulse j, the center of mass will acquire momentum mv naught or the center of mass velocity v naught here. What to do now? Will it be pure rolling? How to check it? I'll calculate velocity of point P. I'll calculate the velocity of point P. So what to do this for this is J into R will set up angular impulse IC omega naught. What is IC? IC is mr square by 2 omega naught. So finally what is J is equal to mr omega naught by 2. There's a one equation, you can write it. There's a first problem. Almost you are having some 15 numericals are there based on this idea, not 1, 2. Just catch the core idea, that one. Now this, because of impulse acting, because of impulse acting, it will acquire linear momentum. So initially it was attached jmv naught. So let me equate 1 and 2. So what is J is equal to mr omega naught by 2. So V naught equal to R omega naught by 2. Which will be greater, V naught or R omega naught? R omega naught, no? So here I'll show that velocity is here. R omega naught will be like this. V naught will be like this. So resultant velocity will be backward direction. So friction, how we should act? Should act forward. This friction, what it does, will increase linear velocity and will decrease angular velocity. So after some time. So shall we call this as a backward slipping? No, after some time. Still, I'll go and check it. So I'll see that the velocity of point P will be still backward only. So it has acquired some velocity V1, angular velocity omega 1, V1. And friction, still it's a backward slipping and the friction will act forward. And after finally, it will attain pure rolling. Then velocity of point P will be 0. Then where V equal to R omega. Now get into the, so what is our question? The final velocity, this V in terms of the J has to be answered here. Agree this? This is the thing. So now what to do now? About what point I can apply conservation of anchor? About axis passing through point P perpendicular to plane. Because there the rate will act here. Normal contact will act. We are discussing ideal rigid body. It's practical thing we can't find out. It's ideal rigid body. in all our syllabus, it's ideal only. If not an ideal, either I'll mention. Otherwise, you have to take it for granted it's ideal only. So applying conservation of angular momentum about axis passing through point P perpendicular. Initial angular momentum due to translatory motion mv naught r clockwise. Listen, then IC omega naught. It's also clockwise is equal to finally mvr clockwise IC omega clockwise. So mv naught r. So as it is all clockwise, now I'll take it positive. What is IC? Disk mr square. What to write omega naught? I do have already this value, no? What is omega naught? Omega naught is 2 v naught by r. And what is omega? V by r. So this will become how much? 2v naught. This will be 3v by 2 or v equal to 4v naught by 3. We can cross check whether we are right or wrong. What do we expect because of friction acting? So what happened to acceleration of center of mass? It will accelerate, no? And there'll be torque. So because of acceleration, the velocity of center of mass must increase. The v should be greater than v naught. Yes, that's what I got it. And look at the torque, retarding torque. The angular velocity should decrease. Calculate omega will be less than omega naught. Fine, finish, very simple. So altogether, what students should do? Somehow you should identify just after impact what will happen to the rigid body. If you can get that condition, you know after this what to do. After this, you know how to solve problem. Means the moment impulse acts, once impulse acts, after impulse acts, then what will happen? I'll show complete description. There's a basic fundamental problem. Based on this, we are going to build up all other ideas now. So when we apply impulse here, immediately after impulse, just after impulse, what is the linear speed? What is the angular velocity? That you have to check it. Then you have to look for backward or forward slipping. Sir, I'm not that good. Still, can I manage? Yes. Still, you can manage. No need to predict this direction of friction. Is it needed? Not needed. Just somehow if you can bring V naught and omega naught, that is enough. Now, how to bring V naught? You know, impulse momentum equation. How to bring omega naught, angular impulse, angular momentum equation. Write them. This you know already. Finish or no? Sir, is it necessary to predict friction? No, I'm just explaining to make you understand. So why backward slipping, sir? All. But in exams, what you should do? Bring V naught, omega naught, and directly write this equation and solve it. Finish or somehow you should get. Write this equation and get it. No need to show in detail all this friction, everything. If they ask you, okay, fine. Otherwise, no need to bother. Now, tell me like, where shall I apply impulse so that it will immediately attain pure rolling? Who will answer this? Now, why is a backward slipping? Because I applied at a point. Now, where shall I apply so that impulse on the disc so that immediately it attain pure rolling? Immediately. Already you have studied, that's why I'm asking. Where shall I apply? Okay, I think better let's take a question. Threshold point is good. Threshold point. Because if you drag the rigid body by applying a force at threshold point, what will happen? Rolling friction will be zero. Similarly here, if you apply the impulse at a threshold point, immediately attain pure rolling. Now, okay, that's what I brought it. So let's go for the threshold point one. Same circular disc, let me take it so that it'll be easy for you to learn. Books, they took solid sphere, I just changed it. I took the, no, the same circular disc. I'm going to apply the impulse